Okay. So, hello everyone. Uh, this Let's get started with the first lecture for DBMS. So, before that, my introduction. My name is Saurabh, and I'm a pass out from IISc in the 2023 batch from the CSA department, and I had given the GATE exam in 2021 and secured an All India rank of 65. So yeah, that's about me. Let's move on to DBMS. So before we get started with the actual concepts, we'll just look at some of the terminologies today, and then probably we can go into much more detailed study in the later classes. Okay. So this is what we'll be looking at in the syllabus. So we have this is according to the 2024 syllabus. So we'll be looking at the ER modeling first of all, following which we'll look at the relational model, then we'll look at relational algebra and tuple calculus as well. So after that we'll look at normalization, the various parts of constraints that we'll be looking at in database management systems, after which we'll be studying SQL, and then transactions and concurrency control, followed by file structures. So, this is kind of a logical ordering that we should be following for the syllabus. So, whenever we are looking at some database, right, so there is a process that is followed for the design. So the first step that is usually followed is a conceptual one, that is to basically try to create a visualization of what you have in your mind about the database. So that is what is called as the ER model. So here we try to create something of a logical view of what we are envisioning the database to be. So here we have the various entities that are going to be in the database and what are the properties they'll have and how they're related to each other. Then we try to concretize this model into the form of tables, which is the relational model. And then the relational model is used as a reference for creating the physical uh, structures in the database. And after that, when whatever operations we need to perform on the data, those are taken care of using relational algebra, tuple calculus, and SQL. So this is the ordering that we'll be following throughout this DBMS class. Okay, moving on. So why we need to focus on DBMS per se is the weightage that is given, right? So in 2023, 5% of weightage for was for DBMS, and following which 2022 had 5% weightage again. 2021 had 8%, and 2020 had 8%, and 2019 had 8% again. So roughly we can expect around 6 to 8% of your marks, which you can secure from this particular subject. And this is not a small number considering the total number of subjects we have when we are preparing for GATE. So we what we have to do is we need to focus on this subject because this if you look at the type of questions
Right.
and you look
Saurabh,
at the
please
subject.
keep highlighting by pen. Okay.
Yeah,
Yeah.
yeah. So yeah, so if we look at the weightage for this, it is roughly around 6 to 8%, right? So if you look at it, the questions and the level of the questions seems to be easy as compared to the subjects if you are well prepared with this subject. So these are the marks that you can secure fully. So 6 to 8% of your marks are guaranteed if you are studying well for this subject, and hence we need to give focus on this. So yeah, moving on. So we'll look at the basic terminology that is used here. So the first question when we are studying, or when we even hear of the word database management systems or anything related to that, the first question that pops into our mind is what is data? Right. So when we think about this, we think of data as anything that can be stored or retrieved or accessed in some form or another, right? So, yeah, yeah. So, data is any fact, right? Observation or measurement that can be recorded. Basically, anything that has a means to be recorded or stored or observed, that measurement is called as data, right? So, an example of data could be text, images, videos. We can also have numbers, right? And yeah, we can have numbers, text, images, videos. So examples would be if you're storing the uh, age for a person, you're storing the name, right? Let's say you're storing the phone number. So this is all data, right? Anything that you can measure, you can observe, and it can be recorded is called as data. It's basically any piece of information, right? It is a piece of information. Okay. Now, so now we have covered data, right? The second thing that we should get familiarized with is database, right? So database is basically a collection of related data items. So we saw what is data, right? We saw what is data. Now, when we have some data items that are related and we put them into some sort of collection where all the similar data items would be stored in an organized manner, that is called as a database. Okay. So the key part to highlight here is related and organized, right? If you're storing related data items in an organized manner, what you have is a database. So we'll look at this in a much more uh, you know like concrete way later on in the classes. But for now, the concept says that the database is a collection of related data items, right? So now, from DBMS, we've seen what is data. We've seen what is a database. Now we need to know what exactly we mean by a database management system, right? So a database management system is nothing but a software, right? It's just a software. And what is the use of this software, right? The use of this software is to manage and organize data in a structured manner. Okay. So we saw that in a database, we are going to store the related data items and we plan to store them in an organized manner. So how will you do that, right? The way you do that is you use a database management system. That is a software. You use this software so that you can manage your database You can store your data items in an organized manner. You can keep related data together, and you can efficiently manage those, right? So that is the use of this software that is called as database management system. And the examples that come to mind are MySQL, MongoDB, SQL Server. So these are the popular examples that we hear of, right? So those are your database management systems. So okay. So we'll look at why we need to have a database management system, right? When we're trying to work with some data. So there are specific reasons that we use a database management system software is they provide features that we can use, right? So the first one is ease of database creation, data storage, and retrieval. Okay. So let's say that you are trying to create a database where you will be storing uh, some particular facts about a person. Let's say you're trying to store the age of a person, right? So you want to create a database. So your database management system has a process that you can use to basically make life easier for you, right? So it will take care of the hard work for you. You give it a command and it is going to create the database for you. Now the next part is the data storage. So you want to store some particular data into your database, right? So you let's look at it this way, right? You have your DBMS, right? Using your DBMS, you created your database. Using your DBMS, you store data into the database, and using your DBMS, you can also retrieve the data, right? So you can either store or access, right? Retrieve can also mean access the data. So retrieval means access. Okay. So the first important feature that DBMS provides is your ease of database retrieval. Sorry, database creation, data storage, and retrieval. Okay. Now, the next important feature that a database management system provides is security and privacy. So this is one of the most important features that we get if we are using a database management system. How so, right? So let's think of a banking application, right? You have your banking data with you, where you have the account number of the particular people in the bank. You have their balance, you have their transaction history, and so on, right? You have sensitive details about the particular person in the bank, right? So what should be the access specification for this sort of data, right? So should everyone be able to access this data, or should we keep it restricted to some specific people? So it's obvious, right? We cannot open up this data to everyone. Even in the bank itself, right? We cannot have all the employees accessing this data. This should be restricted to, let's say, the higher authorities or someone who actually has to perform some operation on the, uh, the bank balance and all of that. So, uh, this is the kind of thing where your database management system will come in, right? You can basically uh, maintain access, maintain the privacy of your data that is stored. So you can give roles and permissions to the different users of the DBMS such that it can make sure that no sensitive data is accessed by an unauthorized user, right? Okay. Yeah. And another key point that comes in is of integrity and consistency. Okay. So let's think about this for a second. Let's take the banking example again, right? So let's think of two people who are trying to make a transaction. Okay. Uh, we have person A and person B. Okay. We have A and we have B. Right. Now the transaction is that person A wants to transfer, let's say, 1000 rupees to person B. Okay. So, what are the steps that would be involved in this transaction, right? The first step would be that the bank balance of person A would be deducted by 1000, right? That is step one. Then the second step would be adding 1000 to the balance of person B. So this is a two-step process, right? Now let's say your step one took place successfully, okay, and your step two failed. Okay, let's say there was a power failure, and because of that failure, your step two failed, and basically the account balance of person B was not credited with 1000 rupees. So what happens in this scenario is A's account has been debited, right? A is short by 1000, but B is not credited with the same amount. So what would happen is on A's side, he would think that the transaction has completed, but B would think that okay, I have not received the money yet, and then that would create a lot of confusion and disputes and a lot of issues in the system. So we need to take care of these scenarios, right? So that is where database management systems come in, right? They help you with integrity and consistency. Integrity and consistency basically, these two terms broadly mean that your data should be in a correct state. Right? Now, let's say earlier A's balance was 1000 and B's balance was also 1000. And after, let's say, this failed two-step scenario, A's balance was 0 and B's balance was 1000 again. Right? So, for the entire transaction to be uh, correct, it should have been 0 for A, but it should have been 2000 for B, right? So our database management system will help us to ensure that either uh, both remain in this state if the transaction was failing, or they reach a correct state, that is this one, that A gets debited and B also gets credited at the same time. So that is what we mean by integrity and consistency. And the next feature that a DBMS provides is concurrency control. Right? What do we mean by concurrency? Is we have multiple processes, we have multiple users working on the data at the same time. So how do we manage those? Okay? So your DBMS has m- many features in place such that we can handle concurrent users and concurrent processes, ensuring that there is no uh, incorrect data, there is no inconsistent state that is arising because of multiple requests to the data at the same time. And the next feature is scalability, right? So scalability is where you want to handle larger amounts of data. Right? When you're handling large amounts of data, you need uh, you need some software that will make things easier for you, right? Because you need something that will help access. Let's say you have 1 million data items in your database. Now, how do you search through your 1 million data items? How do you retrieve one data item out of those million? So you need something that is going to help you make your life easier in these tasks, right? So that is why we need a database management system. That is the scalability aspect of things. Okay. So so if we see the figure on the right, it depicts how your database management system comes into play. Right? So we have the different databases here, right? We have a relational database, we have a hierarchical database, we have flight files and objects database, right? So there are different kinds of database. So and this is your entire storage area, right? This is where your data is actually stored. Now your database management system comes in between the storage area and either a user, other database management system, and applications. So if we think of what exactly is happening here, your database management system is coming in as an interface, right? It is coming in as an interface between users, applications, and the storage. That is your database. So what it is doing is the users and the applications need the data in some form, and it needs the data in some with some good presentation. It needs the data in some readable format. So that is where your DBMS comes in. Your DBMS takes the data from the storage area. Okay? It takes the data from here and it gives it to the applications or users or other database management system in a way that can be human readable, that can be accessed easily by an application, and so on. Right? So it basically presents the data in a format that is required to them. Instead of directly accessing the data from this database and then trying to convert it into something you want, your DBMS takes care of these things. It acts as the middleman between all this. Right? So you basically, as an user, you can tell the DBMS, okay, I want my data in this format. Please provide it to me. And then the database management system will go into the storage area. It will look through the databases, and it will get the data organized in whatever form you want and then return it back to you. Right? Okay. So this is the use case scenario for a database management system. Okay. Is that clear? Okay, good. Okay, so the with that in place, let's move on to the first topic, that is your ER model or entity relationship model. Yes. So, what exactly is an ER model? Okay. So, the ER model is used for basically identifying entities to be represented in the database. Okay. And a representation of how those entities are related. Okay. So now we've seen this word entities a lot of times. So we'll define what an entity is. Okay. And then we'll come back to this definition again. So what is an entity? An entity is an object with a physical or a conceptual existence. That's it. It can be any object that exists, and we can call that object as an entity. Okay. So, uh, do we have examples of entities? Yes. Let's say we have car. Is car an entity according to the definition? Yes. So, car is an entity, right? Because it has a physical existence. Okay. Now, let's say we have another object, that is bank account. So, is bank account an entity? It is, right? Bank account is also an entity which has a conceptual existence, right? So, here we've defined two entities. Okay. One is the car, the second is bank account. So, this is your entity. Now, when you go to an entity, you think of certain properties that an entity has, right? So, for example, a car has some properties, that is its model name, its registration number, and the owner of the car, whether what type of car it is. Is it an SUV? Is it a sedan? And so on. Similarly, for a bank account, we have some properties, right? We say who owns this bank account, what is the balance in the bank account, what is the contact number of the person holding the bank account, and so on, right? So we have these properties that define an entity. So those properties are called as attributes. Okay. So the properties of an entity are called as attributes in the ER model. Okay. So, okay, now coming back to this definition of AR model. The ER model is a model for identifying entities to be represented in the database and a representation of the relationship between the entities. Right? So we'll look at the relationship between entities examples in the next class. But the important thing to notice that two entities in the world can be related, right? So let's say we have another entity here as person. Okay, is can a person be related to a car? Yes, it can be, right? As an owner, exactly. Similarly, for a bank account, it can be the whoever opened the bank account, right? So that is some sort of a relationship between the entities. So that is exactly why we use the ER model. We use it to identify entities that we'll be representing in the database, and we use it to represent the relationship between the entities. Okay, fine. So let's move on. Okay. So what we'll do is we'll look at some examples. Okay. Uh, let's say we have this. Okay. Is a student an entity? Okay, good. So what can be the properties associated with a student or the attributes? Okay. Age. Okay, good. Gender. What else? Okay. We have name. We can have roll number, right? Date of birth. We can have phone number. We can have, let's say, address, right? So we can have these properties that are associated with the student. So what do we call these properties as in the ER model? Yes, these are the attributes. So your this is your entity and these are your attributes. Okay. Mhm. Now let's think of one more entity. We have vehicle. Okay. We have one more entity as vehicle. What can be the attributes for vehicle? Okay. We have mileage, model, color. We have owner, right? We can have the registration number, can have the manufacturer. Okay. And so on. We can think of other properties as well. These are your attributes again. Right. So, is it clear what an entity is and what are attributes? Okay. The next thing we'll look at is entity type, entity, and entity set. Okay. We have seen what an entity is. Right? So, what we'll define what an entity type is. An entity type is a blueprint for entities. Okay. So, uh, we've heard of this word somewhere, right? Blueprint. Uh, do you know where this term blueprint comes in? It comes in another concept of computer science, right? Okay. So, do you remember classes and objects? Yeah. So, a class is called as the blueprint for objects, right? So, basically, we in classes and objects, we create a class and we then instantiate the class to create objects, right? If we have one class, we can create 10 objects of that class. And those objects will have the same behavior and same properties as the class. So in entity type, we have a similar definition, right? We have entity type as a blueprint for entities. So you can think of your entity type as a class and your entity as an object. Okay. So you have class, you have objects for, okay, let me write it above. You have class and objects. You have entity type, entity. Okay. So in entity type, you will define the properties and you will define the type of, basically you'll define that this is the properties that an entity can have and this is the behavior that it can have. And then once you create an instance of the entity type, you have an entity similar to what we have seen in classes and objects. An entity type is just a logical representation, and once we instantiate the entity type, we get an entity that is basically an object with a actual existence. Okay, is that clear? Okay, okay. So the next thing we look at is entity set. Your entity set is nothing but your collection of entities. Okay, so we'll look at an example and we'll try to make things clear. Okay, we have entity type, we have entities, and we have entity set. Okay. Now, in the previous slide, we had seen examples, right? We had seen this student and vehicle. So, what do you think is a student? Is it an entity, entity type, or an entity set? Okay. So, your student is something that is defining the properties, right? It is defining that, okay, we can have an entity, student, and we can have the properties associated with it, such as the age, gender, name, roll number, date of birth, phone number, and address, so on. Right. So what exactly we have done here is we have defined a blueprint for a student, that your student can have these properties, and it can be represented in this format, right? So your student becomes your entity type. Okay. Your entity is anything with a physical or a conceptual existence, right? So, can you think of uh, an entity with the given entity type as student? Okay, now we have defined that we have an entity type as student, and it can have the following properties. So, now what we want to do is we want to instantiate this entity type and create an entity with an actual existence. So what do you think we can have as an entity? Okay, we can have, let's say, okay. So yeah, so your student is an entity. Okay, I'll give you an example that will, I think, clear it out. So we have, let's say, we have a student, let's say Sanchita. Okay. So now Sanchita is a student who is going to have the following properties, right? Age will be, let's say, something 20. Gender will be female. Name, roll number, you'll have one. You'll have date of birth. You'll have a phone number, and you'll have an address, right? So now these properties have been instantiated to give a real world existence, right? So up to this point, this was just a blueprint, right? This was just saying that your student can have the following properties, but there was no real world existence for it. Now we have instantiated a student object, that is Sanchita, from these from this entity type student, and we've got the student who has some age, some roll number, something. So now Sanchita is actually a student with a real world existence. So Sanchita is an entity. Okay, do you get that? Okay. So we can have, let's say we have Shubham, and so on, right? So we can have these entities. Your entity type is student. You have entities, let's say Sanchita, Shubham, and so on. And now what would be the entity set? Your entity set is nothing but your collection of entities, right? So what would be the collection? It would be a set that has Sanchita and Shubham. Okay. So this is nothing but your entity set. Now let's look at the other example that we saw where your entity type is vehicle. Okay. So what do you think will be the entities corresponding to this entity type vehicle? Exactly. We can have Scorpio. Let's say we have another I-20. We have Innova, right? So we have uh, three entities, that is Scorpio, I-20, Innova, and so on. We can have more entities that are instantiated from this entity type that is called as vehicle. And all of these vehicles like Scorpio, I-20, or Innova will have the following properties. Scorpio will have some mileage, let's say 20 kilometers per liter. The model name is Scorpio itself. The color, let's say white. Owner would be something. There would be a registration number, right? KA53 something something. And the manufacturer will be Mahindra, right? And so on. Right? Okay. Uh, is that clear? Okay. Now, what would be the entity set here in this example? Yes, it would be a collection of all the entities. It would be a set that has Scorpio, I-20, and Innova. Okay, good. Okay, is it clear what an entity is, what an entity type is, and what an entity set is? Okay, okay, great. Okay, so the next thing we'll look at is attributes. So we saw that an attribute is nothing but a property, right? So your attributes define properties for the entity type. Okay. So we saw this, right? For the entity type as student, the attributes were roll number, name, age, and so on. Right? And for car, similarly, we had seen model, mileage, and so on. Yeah. So these were the attributes for the entity type student and car that we had seen. Okay. So in attributes, we can have different types, right? So in the different types of attributes, what we do is we have a classification of these attributes. Your attributes can either be simple or they can be composite. They'll be either single valued or multi-valued, and they'll either be stored or derived. Okay. So we'll look at these classifications of attributes. Okay. So the first one is simple versus composite attributes. Right? So, as the name suggests, a composite attribute is one which can be decomposed into multiple attributes. Okay, and similarly, a simple attribute is something that cannot be decomposed or cannot be divided into other attributes. Okay, so I have this attribute name. So, what do you think? Would it be a simple attribute or a composite attribute? It is composite. Okay. Why? Yeah, exactly. We can decompose this into first name, middle name, and last name. Right? So your name becomes your composite attribute. What about first name, middle name, and last name? Yeah, they are simple. Exactly. So we have name as a composite attribute, first name, middle name, and last name. These are simple. Can you think of one more example of a composite attribute? Address. Excellent. Address is another composite attribute. We can decompose this into, let's say, the street, then we can have city, and we can have the state, and we can have pin code. Right? Your address is a composite attribute that can be decomposed. Okay. So we have seen simple and composite attributes. Simple attributes are those that cannot be decomposed, and composite attributes are those that can be decomposed into multiple attributes. That's it. Okay. So the next classification we have is single valued versus multi valued attributes. Okay. So basically, an attribute that holds multiple values is multi-valued, and something that will hold only a single value is a single valued attribute. So can you think of an example for a multi-valued attribute? Exactly. Phone number. Phone number is a multi-valued attribute. It can have phone number one, phone number two, and so on. Right? One person can hold multiple phone numbers. We have phone number. Can you think of another multi-valued attribute? Email. Good. We can have, let's say, the cars owned by a person, right? These are all multi-valued attributes. Okay. And on the contrary, we have single valued attributes. These are some attributes that can hold just a single value. We can have age, right? One person cannot have multiple ages, right? What else do you think would be a single valued attribute? Gender, good. Okay, good. Gender, date of birth. We can have the Aadhaar, right? So that is your single valued versus multi valued. One more classification that we have to look at is stored versus derived attribute. Okay. So a derived attribute is one that can be basically a derived attribute can be derived from other attributes, and stored attribute is something uh, that we have recorded in the entity. I think an example will make this much more clear. Let's say we have student, okay, and your entity type student has a property as date of birth. Okay, so since we have defined date of birth as an attribute for the entity type as student, we call this as a stored attribute. Why? Because every entity that will be instantiated from student will have date of birth stored. Okay, is that clear? Okay, so can you think of a derived attribute? Exactly. We can derive age from the date of birth, right? So we can derive age from date of birth, and that makes your age as a derived attribute, right? Derived attributes are those that even if we do not store them, we can still have them in the entity, right? So if we have the date of birth, we also have the age of the particular student. Okay, is that clear? Okay. Well, so there is one important attribute that we need to look at, that is the key attribute. And key attribute is the attribute which uniquely identifies each entity in the entity set. Okay. Okay. So we had seen the entity set of students that was, let's say we have Sanchita, we have another student Shubham, we have, let's say, Manav, and so on. We have many students. So what do you think will be an attribute we can use to uniquely identify each entity in this entity set? Exactly. Roll number, right? So that makes your roll number as the key attribute, right? The key attribute is nothing but the attribute that uniquely identifies each entity. Now let's say we have vehicle. What do you think will be a key attribute for vehicle? The registration number. Good. Okay. And let's say we have another, let's say bank account. What do you think will be the key attribute for bank account? The account number. Okay, good. So that is your key attribute. Is it clear up to here? Okay. So we'll do some examples with everything we have seen so far. Okay, I'm giving you an entity type. That is patient. Right? We have a patient in a hospital. So what can be the attributes for this entity type? Okay. Name, age. Okay, good. We have the patient ID. We have the gender. Say we have address. Okay. We have Aadhaar. Let's say we have the date of admission, right? We have phone number. Okay. So what do you think would be the key attribute? Okay, patient ID can be the key attribute. Good. Uh, what do you think a name would be? Is name a composite attribute, simple, single valued? Okay, it is composite, right? What about age? Age is single valued, right? Is age also a simple attribute? Yes. Okay, so we get an important point here is that an attribute can be single and mm, simple both as well. So we can one attribute can be both. Okay. So patient ID. What about patient ID? What kind of an attribute is it? Okay, it is key attribute and it is also simple and single, right? Gender. Gender is again a single valued attribute. Address will be composite. Aadhaar will be a single valued attribute. What about date of admission?
Yeah, sure up. Like we'll continue for a while.
I think I'll need 10 15 minutes.
No problem. Please continue. Thank you.
Yeah. Yeah. What about the date of admission? That can be a multi-valued attribute, right? Because one patient can be admitted multiple times. It can be multi-valued. Is that clear? And phone number can again be a multi-valued attribute. Okay, fine. So let's recall what we have seen in today's class. Okay, we'll quickly do a recap and then we'll stop for today. Yeah. So we saw what is data, what is a database, and what is a database management system. Okay. So am I not audible? Am I audible now? Okay. Okay. So we'll do a quick recap of what we saw. The first thing we saw is data. Data is nothing but a piece of information or any fact that can be recorded. That can be in it can be a text, an image, video, a number, anything, right? And a database was a collection of related data items that is stored in an organized manner. And then we saw what is DBMS. DBMS is a software that helps us to manage and organize data in a structured manner. Right. Then the next thing we saw is the need for DBMS. So we saw the features, that is the ease of database creation, storage and retrieval. Then we saw security and privacy. We saw the integrity and consistency, that is maintaining the correct state of the data. Then we saw concurrency control and we saw scalability as the key features that a database management system provides. Then next we started with the entity relationship model. We saw what an entity is. We saw what an attribute is, right? We defined this. Then we saw what an entity type and an entity set is. An entity type is nothing but a blueprint for entities, and an entity set is nothing but a collection of entities. It is a set. Okay. The important point here was that entity type to entity relation can be thought of as the relationship between classes and objects. Okay. Then we saw the different classifications of attributes. Okay. Your attributes can either be simple or composite. They can be single valued or multi valued, and they can either be stored or derived. Right. Uh, com- a composite attribute was one where we can decompose it into multiple attributes, and the simple attribute was one which cannot be decomposed. And single valued was an attribute that can store just one value, and multi-valued is an attribute that will have multiple values in it, such as a phone number or an email, right? Then the next classification we saw was stored versus derived attribute, where a derived attribute is one that can be, basically we can derive it from another attribute, and we need not store that attribute. So we saw the example of date of birth and age for this. And the last thing we saw was the key attribute. That is a special type of attribute that uniquely identifies every entity in the entity set. Okay. And we saw this example. Okay. So is it clear for today's class? Do you have any doubts? Okay. So I think then we can close it for today, and see you in the next class. Okay.